Hi everyone, here we have Rebecca Hufstetler. She's a fourth year PhD candidate student at the University of Oregon. Her area of expertise is in seismic tomography and on imaging on the crust and also what happens inside volcanoes. So Rebecca, how are you feeling today?
Hi, I'm feeling great. I'm really excited to be here.
I'm really excited to interview you too. My first question is, how did you get into deciding into a PhD program in seismic tomography and imaging on what goes inside volcanoes?
So it was kind of a long-winded process. Um, I guess it started, growing up, you're trying to figure out what you want to do and where you want to go with your life. And I was always really good at like very, math and scientific and science kind of concepts. And so I ultimately ended really pursuing physics. I found myself good at like, my physics classes and stuff. And I ended up going to college as a physics major because I felt like I could apply it to a lot of different things. And I just didn't really know what I wanted to do yet. And so I just kind of took it year by year. And eventually what actually happened is I did a program with a local community college in my hometown that took you out to Wyoming and Colorado and Montana. And you took two geology courses and you basically got to immerse yourself in like mostly focusing, in the Grand Teton Range and those mountain building events. And you just learn basic geology concepts. And that was my first time ever going out west. I was, born and raised on the East Coast. And that was my first time ever taking a geology class. And I totally loved it. I loved being outside. I loved studying it. And so I eventually ended up deciding I wanted to combine, what I'm good at and what I really like. And so I tried to take these physics concepts that I seemed to have a knack for and apply it to geology and the earth. And I kind of narrowed into this geophysics realm. And so it just kind of, it just kind of kept going from there. I really wanted something. I decided I wanted to work with geohazards because I think, helping people, you know, build resilience against hazards and be able to mitigate their effects and that kind of thing was something I wanted to do where I could have some sort of scientific job, but feel like it was really helping people and helping the earth. And so then I slowly, I went into geohazards and then it basically just led me to seismic tomography and volcanoes, right? um, and led me to what I do now, which is perfect because I'm applying, what I'm good at and what I like and doing it in a way that I think is impactful and meaningful. So it makes me, continue to stay passionate about it. So it was a very, iterative and long-winded process, but just kind of trusting myself and the people around me just led me to where I needed to be.
Oh, that's amazing. I also like being a scientist and also like having a society important because once you impact society and help with like your grain of sand and anything that you do is really heartwarming and really wholesome. So I really do love it.
Right. Especially because science can move so slow. It's nice to feel like you're still doing something that is really helping and matters.
I full on agree. 100%. We as scientists have to help the public and we have to do lots of outreach in order for people to be interested in the job that we do, but also like help out with what we do as well.
Mhm.
So, what type of instrumentation or progress or programs do you use to image the crust and observe dynamics of volcanic processes?
Yeah. So taking one step back, what I'm doing ultimately is trying to locate magma chambers beneath volcanoes for what I do. Because that way we can know, where the magma chamber is, how big is it, how much of it is melt, these kind of things. It's important to understand what's going on in the crust of volcanoes. So to do this, I use seismic methods. So we use seismometers would be the instrumentation, basically just little stations on the surface of the earth, receiving these pressure waves that travel through the crust after an earthquake happens. And so I'll take, these earthquake data sets for most of my work. The data set itself can vary, but an earthquake happens somewhere and we know when and where it happened. And so we have that information. And then we have a seismometer out and we know where that seismometer is. And we can, figure out how long it took those waves to travel from the earthquake to the seismometer. And, using the properties that I know, okay, I know the wave left the earthquake at this time and arrived at the station at this time. Based on how fast or slow it gets there, I can kind of try to deduce what it encountered along the way. So, when I have a lot of these rays, then they'll cross and it'll give me like a better resolution and a better picture of what's under the crust. But but ultimately the instrumentation is the seismometers and a lot of coding in, MATLAB, Python, Julia. Usually those are the main ones. Um, Most of my work is sitting on my computer coding. But it's cool because like I said, we call it the inverse problem where you have this set of observations, and in this case it would be like, travel times of these waves to the seismometer. And you're trying to figure out what the actual factors are that created those observations. And so this is opposite of like what is called the forward problem, where you have the causal factors and you're just calculating the outcome. Where when I have these outcomes, there's many different causal factors that could cause that outcome, or there's many different, distributions in the crust that could cause the waves to arrive when they do. So I get to use a lot of user input, and like it's like a puzzle in my mind, like I have these pieces, and like what is the most logical way to put them together that actually makes, a picture of what's underground that makes sense.
That's super amazing and cool. I've only dealt with earthquakes produced by plate tectonics, but I believe that volcanic seismology is super interesting.
Yeah, it's a cool way to combine both worlds, right? Like I wouldn't necessarily call myself a seismologist. I don't know too much about like earthquake mechanisms and that kind of thing, but I get to like have a foot in both fields. Volcanology, same thing. Like people will talk about these crazy chemical compositions, and I can't necessarily keep up with that, but I get to kind of have a foot in both areas. It's fun.
Well, you definitely have the best of both worlds. I do agree. So, how did you find out about the science communication internship at Earthscope? Because you, Alex, and I were both science communication interns. And what part of being a science communicator do you enjoy the most?
Yeah, so to find this internship, I think I was just looking online. I don't think I heard about it from any particular person. I already kind of kept up with Earthscope, like I followed them on some social medias and stuff. And I really just was looking for science communication internships because that's really what I wanted to do this summer. I think that's sort of the next step for me as a scientist. I have a pretty good scientific background, but I want to make sure before I finish grad school that I'm fully equipped with the ability to communicate my science in a way that makes sense for whatever audience it is. And so I was just kind of looking around online, and I looked at Earthscope's website and I just saw it and I was like, yeah, that seems like exactly what I want to do. And it seemed like it had great flexibility, which it does. You get to work on a ton of different things and whatever's really piquing your interest, which is like part of it. And it just, yeah, it worked out.
I also enjoy the flexibility of it because it lets you do your grad school work, but it also gives you these skills, these communication skills, which are so important in order to like communicate to the public about what we do, and what we do is interesting as well.
Yeah, yeah, there's a really awkward gray area between scientists and communicators. I think this internship fills that nicely by, I feel like frequently this area is not populated by scientists, but by like a communicator trying to learn science. And so creating that space for a scientist to be able to learn the communication skills is like not as common as you would think. And it's a really important skill for me to develop, I feel.
Oh, absolutely. I absolutely 100% agree. Like, I have professors that always recommend me pedagogic courses and also like communication, outreach, and public speak because it's very important for you like to come across with the correct terms, but also like for different types of populations and different types of public in order like to understand what you'll be doing is really great. Like, for example, from kids to middle schoolers to like teenagers to like adults.
Hmm.
Um, what advice would you give to aspiring undergrads who would like to do the same thing that you're doing right now as a PhD student, or to high school students who want to study geoscience or any STEM related fields?
Yeah, okay, interesting. I think the most common answer you're going to get is that you need to talk to people. If you want to go to grad school, you're going to get told you need to send emails, be annoying, be persistent, because that's how you're going to get in. I think for me specifically, this doesn't necessarily apply to everyone, but for people who know like what imposter syndrome is, I think I would want to tell everyone that that's not real and you are so qualified for whatever you want to do. I think that I think that imposter syndrome is really common in science specifically and especially in minorities. Because I just feel like, some projects can be a little bit ambiguous. Like there's not one perfect skill set that fits a project. And so I think many people will be like, oh, maybe I won't apply for that because I'm not, that's not my qualifications. But I came to grad school with basically no geology background. I really, leaned into the physics side of things. And I told my advisor this, like, I don't have the geologic understanding, but I have the understanding of like the physical background. And your advisor will work with you. And I think that your actual level of expertise does not matter near as much as your tenacity. I think everything about grad school has to do with like working hard, being willing to look things up on your own and be more, self-facilitating. Like you take care of your problems yourself. And less to do with your actual expertise and knowledge. Like the the professors don't care if you don't know something. They care if you don't have the tenacity to go look it up yourself and go teach yourself. And so I just don't believe that imposter syndrome that you're not qualified because I think anyone can be qualified for grad school in science, and it's just all about your effort and your willingness to put your best foot in.
I'm definitely taking that advice.
You gotta tell yourself over and over it's not real because your brain wants to tell you like, oh my gosh, these people are so smart. They know so much. I can't keep up with this. And it's like, no, 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 you can. You totally can.
Oh, for sure. I think it's when you get into grad school and you find a research topic you have never done before, you're kind of like really nervous and you have this anxiety, like, if I could like go up to that expectation of my professor. But I think that the most wholesome advice is yours. I really honestly do. And what I've
Well,
learned
I
so
hope some
far,
people get to hear it because
yes.
it's so needed. I needed that going into grad school all the time. You're like, well, should I apply for this? Can I, why not apply for it? You're way more qualified.
Exactly. It's like, why not apply for this? And also my advisor always tells me, you know more than you think.
1000%. You get surrounded by people who know so much about such niche topics that you need to remember they know nothing about this opposite topic. Like everyone has their specialty and you're totally qualified.
I full on agree. Also, aside from being such a cool geoscientist and also a cool physicist as well, because you dabble into both worlds, like what other hobbies do you have?
Yeah, well, I live in Oregon, and so I do a lot of hiking and camping and fishing and that kind of thing. Particularly now because it's just so gorgeous outside in Oregon in June, and so I'm trying to get outside on the weekend and do some hiking and spend some time in the sun. And then other than that, I'm a big soccer player, so I play in like an adult league in Eugene and try to keep that going from my younger days. And I also like coach middle school girls in the soccer teams, and it's so fun. And it's also really great because I'll frequently have, practice in the evening after work. And sometimes it can be really hard if you're having a frustrating day of coding or something. It can be really hard to pull yourself away from it and pull yourself away from the frustration. And so I have to go to these things, I have to coach them. I have to go outside. And then you're working with kids, so you have to be like happy and willing, and you can't be having a bad day if you're working with kids. So I go to these practices and it's so helpful for like pulling me out of a funk if I'm having like a bad coding day because I get that fresh air outside. I interact with children, it's like twofold. It's good for me and it's good for them. And it's a good like secondary thing to have that forces me to step away from science sometimes. And it's really fun. They're great.
I really do agree. Kids are like sponges. If you're
Yeah.
having a bad day, they're gonna know about it. And also, as scientists, it's really good for us to have hobbies and to de-stress because grad school is tough. I do both. I'm a full-time employee and I also do grad school, and I need those hobbies in order for to keep myself sane and centered.
Yeah. Yeah. You do your work better if you take a break from it, even though it's hard to feel that way sometimes.
Exactly. Most especially with coding, like if you
Hmm.
take a step back and then look it back again at your codes, you're gonna figure out what goes wrong. But if you just stay there, like beating yourself up, it's like
Yep.
the stress builds up. So
This
it's
is
good
something
for
I struggle with.
yeah. So it's really good that you have those hobbies to go back to.
Yeah, absolutely.
Rebecca, I really want to thank you so much for this interview. I wish you the super most awesomest like day today. Thank you so much for saying yes. Thank you for your patience as well. And I wish you the very best in your PhD and in this internship. And may you do lots of nice things for our school.
Thank you so much. I can't wait to see how it evolves. It's going to be a lot of fun this summer.